Hey friends, welcome back to the channel and to episode 16 of Research Paper Summary. In today's video, I'll be covering an EMNLP 2020 paper, CrossWeigh Training Name Entity Tagger with Imperfect Annotations. The paper found that the Cornell 2003 NER dataset contains a lot of label mistakes, and so they proposed a framework to automatically alleviate these mistakes during the model training process. In this video, I'll first go over the context and contributions of the paper. I'll then dive straight into the CrossWeigh framework, and lastly, I'll finish up this video by sharing some of the experimental results and analysis. I hope you find this video useful. Let's get to it. If you're new here, my name is Ryan. I'm a PhD student based in London, and on this channel, I share my journey as a student entrepreneur, covering my PhD research, my entrepreneurship journey, as well as different life design topics. If you're a student, entrepreneur, or both, consider subscribing. Human annotators aren't perfect. They do make human mistakes in label annotations, and these mistakes tends to hurt the training and evaluation process of the model. The paper decided to explore the NER task. Specifically, they performed a deep analysis on the popular NER dataset, the Cornell 2003 dataset, and found that 5.38% of the sentences in the test set contains label mistakes. This is a significant error rate since the state-of-the-art model in the Cornell 2003 NER dataset is already around 94% F1 score. It will therefore be very useful to fix these errors and come up with a method to alleviate some of these mistakes during the model training process. And that's exactly what the CrossWeigh paper has proposed. The overall contributions of the paper are as follows. First, they manually corrected the label mistakes in the test set of the Cornell 2003 NER dataset, which results in the Cornell 2003++ dataset. They also re-evaluated the popular NER models on the new dataset and found that they all tend to perform at a better F1 score. Secondly, they proposed the CrossWeigh, a novel framework to automatically alleviate these labeling mistakes during the model training process. The paper applied the framework on 3 different datasets, and the results showcased the robustness of the framework in delivering strong F1 score improvements. Let's now dive deeper into the CrossWeigh framework. Overall, the CrossWeigh framework aims to A. Identify potential label mistakes, and B. Reweighting those mistakes to reduce the impact in the training process. Let's now take a look at the CrossWeigh framework. First, let's understand the general label mistakes that we are trying to alleviate here. As an example, the entity Chicago here can either be a location or an organization type entity. You can see in the original training set that there is a label mistake for Chicago in the second instance, where the team Chicago is supposed to have organization entity type rather than the location entity type. These label mistakes will result in wrong predictions during the testing time, as shown here, where Lakers was predicted location rather than organization given similar context. The proposed framework to alleviate this problem is called the CrossWeigh, and it consists of 2 modules. The first is the mistake estimation module. It identifies potential label mistakes in the training data through cross-checking. With this module, we would like to have high recall and precision in that we want to find as many sentences with label mistakes, yet still avoid the correct sentences. The basic idea here is similar to the k-fold cross-validation. First, you split the training data into k-folds and train k number of NER models separately. Each NER model will be evaluated using sentences in the holdout set. Within the holdout set, we remove any sentences that may lead to easy predictions. What this means is that all training sentences that have entities in the test set are excluded from the training process. This is known as entity disjoint filtering. What this does is that the models are now required to make prediction without prior information of the entity, and this will allow us to detect any label inconsistency between our NER models. Each NER model will make predictions for the holdout set and compare the model output with the original label for each sentence. Sentences that have the same model output as the original label will be considered correct. Otherwise, it's considered to be a potential mistake. We will run this module multiple times with different k-folds, and the results will give us an estimation of the potential mistakes for each sentence in the training set. For the Cornell 2003 NER dataset, the paper has found that the 10-fold gives us the most effective results with reasonable running time. The second module is the mistake reweighting module. Here, the idea is that we want to lower the weights of sentences that was estimated to be mistakes, so that they have less impact during the NER model training process. The paper has chosen to use the exponential decay weight function, since as the number of iterations increases, the confidence of being correct decreases. Let's now look at the Cornell 2003 experimental results with the CrossWeigh framework. Overall, as you can see here, the CrossWeigh framework tends to lead to a higher F1 score in both the original Cornell 2003 and the corrected version, showcasing the effectiveness of the CrossWeigh in alleviating incorrect annotations during model training process. Additionally, you can see that the standard deviations tends to be smaller with CrossWeigh framework, suggesting a more stable results. In order to assess the importance of the entity disjoint filtering, the paper has conducted a small ablation study to see the performance difference. As you can see here, without the entity disjoint filtering, the F1 score seems to be lower than the CrossWeigh score, showcasing the importance of the entity disjoint filtering in reducing overfitting risks in estimating the mistakes. Lastly, we also compare our entity disjoint method with the random discard methodology. And here, as you can see, our CrossWeigh still outperforms the random discard method. And that's it for today's video. Outside of my PhD research, my friends and I have been developing a platform called Zeratin, a platform that converts non-fiction books into actionable steps so that you can spend less time reading and more time taking actions. On the platform, we have over 150 plus actionable steps from many best-selling books. It will mean a lot to us if you can check it out and let us know what you think. I will link up in the description below. Thank you for watching. I'll see you guys around next time.